everybody, this is Mrs. Ewald signing in, and I'm going to go ahead and take you through the steps to balancing a redox reaction. Now, the first question that should come through your mind is, why do we need to balance again? Well, the difference is this. Now that we're dealing with redox reactions, remember, we're dealing with a reduction and with an oxidation. And so you should have already watched Miss Heaton's first two podcasts taking you through the introduction of what a redox reaction is, as well as how to determine oxidation numbers, and also in the second podcast determining your oxidizing agent as well as your reducing agent. So you should already have the meat and the potatoes as far as what an oxidation reduction reaction looks like. The difference is that now we need to balance because we still need to follow the law of conservation of matter. And we need to know that what goes in must come out. The difference now is that not only are we just balancing our non-hydrogen, non-oxygen, all that kind of stuff, we also need to make sure that we are aware of the charges. Because the difference now is that redox reactions, we're dealing now with the movement of electrons. That is the big thing. And I'm going to refer to electrons a lot as E to the negative sign to refer to it as an electron. So why do we need to know this? Well, we need to be able to show the movement of the electron transfer. So we need to know where the electrons are going. So we're looking at the transferring of electrons. And the application to this is electron flow in batteries. So we're going to be using this information to understand more about how batteries work. And so being able to have a battery, we have a positive and a negative end of a battery, and being able to show, in order to, let's say, light up a light bulb, right? We need to be able to show the movement of those electrons. And the idea that electrons are going to be flowing from low energy to high energy. And so it moves from the negative to the positive end, right? That's the way the flow of the electrons are going to move. Electrons, right? And of course, balancing is fun and relaxing. So we get to repeat what we've already done before with balancing and sit back and relax. So let's get cozy. And I'm going to take you through the 6 steps to balancing. This is the handout on the back of your oxidation rules that you should take out. Refer to this along with me, as well as have a separate sheet of paper in order to write down your example. Okay, so let's get started. Let's give you a specific example of a reaction, so a redox reaction. And so let's have Cr2O7, so dichromate ion, reacting with NO2 minus to form chromate, or chromium ion, plus 3, and nitrate. So we have nitrite forming nitrate and so on. Now let's go through a little bit of review from Miss Heaton before we get started. Now the first thing we need to do, so our first rule, and I'm just going to go back and forth here, our first rule is to assign oxidation numbers to everything. So that is my first step. So that's what I'm going to do here. So we could kind of color code it here. So my first step is to identify all of my oxidation numbers. Reason why, I need to figure out what is being oxidized, what is being reduced. So let's go through our rules. So looking at dichromate, I have an ion. All of my oxidation numbers need to add up to -2. Oxygen will be -2, so we have 7 of them, so it'll be -14. And then chromium, I have 2 of them. What should this number be in order for me to end up with -2? So it would be +6 because 12 minus 14 equals -2. So those are my oxidation numbers there. Next ion, oxygen again has to be -2. This all needs to add up to -1, so that's -4. Nitrogen then has to be +3 because 3 minus 4 equals -1. So those are them. This here, my oxidation number is the charge of my ion, so that's +3. And then the last one, this all needs to total up to -1. Oxygen is -2, so that's -6. Nitrogen has no choice but to be +5, because 5 minus 6 equals -1. Now looking at my oxidation numbers, I could determine what is being oxidized and what is being reduced. If you have an increase in oxidation number, that would be oxidation. So an increase in number, we know that that is going to equal oxidation. Remember, oxidation is the loss of an electron, so you're becoming more positive. If you have a decrease in number, we know that's reduced, so reduction. If you are reducing, you're gaining an electron, so you should be becoming more negative. All right, now let's identify what's being oxidized and what's being reduced in this whole reaction here. So what we're doing is we're taking this ion, reacting it with this ion to form these two. Notice a big difference than what we've done before with balancing is we're really dealing with ions, and so things with charges. So we have to be aware of those charges in order to balance this and know what's going on. So my chromium, if we look at this alone, the chromium is going from +6 to +3. So I am decreasing my oxidation number, so therefore I know that this is being reduced. So this is undergoing reduction. So it is decreasing in number, it is gaining electrons, becoming less positive. My nitrogen, because notice my oxygen remains the same. It goes from -2 to -2, nothing occurring there. But anytime you have reduction, you must also have oxidation. So oxidation and reduction must occur together. The nitrogen is going from +3 to +5. That is increase in oxidation number. So this must be oxidation. It is losing electrons, becoming more positive then. So I have identified what is being oxidized and what is being reduced. So what is being reduced and what is being oxidized. So those are my two parts of my reaction. Now, the next thing we need to do is start to balance this. But notice there's a lot of stuff going on here and a lot of charges. What we need to do, the best way, is to break this down into two parts. And what we do is we break it up into the half reactions. So we're going to now do our next part, which is writing out the half reaction for oxidation first, do what we can there, write it out for reduction, do what we can there, and then bring it back all together. It will make your life a whole lot easier. So, following along with the rules then, let's write out the half reaction for oxidation, which we've already identified here. So in my second step, let me do this in red, I'm now going to write out my half reaction. So that's NO2 minus forming NO3 minus. So I'm pulling this part out here. Okay? Now, what it says in my rules is to balance the mass. And so simply, I'm going to look at my non-hydrogen, non-oxygen elements first. And in this case, it would be nitrogen. And I would make sure that that is balanced first. And it is. So I'm good with my nitrogen. I have one here and I have one here. Next is my oxygen. So I looked at my non-hydrogen, non-oxygen. That looks good. Next thing I need to do is balance my oxygen. I have 2 on the left and I have 3 on the right. The only way I can balance this is to add water on one of these sides. Now, we can only add oxygen. We can't remove the oxygen. So I'm going to add it now to the left side. So now I have 2 plus 1, so 3 oxygen on the left and 3 oxygen on the right. That takes care of my oxygen. Now I need to, because I've added the water, I have now added hydrogen ion to the left side of my reaction. So what I need to do is make sure that that balances. And now this is balancing in a acidic environment. And so if it's acidic, what should be present in the solution? Hydrogen ion. And so I'm going to be able to show my addition of that by, if I have 2 hydrogen here, I need to then show on the right side 2 hydrogen ion on the right. And so now my hydrogens balance. That takes care of step 3. My last thing in here is to balance the charge. Now, we've never dealt with charges before with balancing. This is what makes redox balancing different. What I need to do is first look at, well, I have a -1 on this side of the reaction. and I have a negative 1 because I have 1 nitrate ion here plus 2 hydrogen ion. So that's 1, 2, right? So that would be a plus 2. So I have negative 1 here and negative 1 plus 2 on the right. So what I need to do is make sure that this all balances. I need to add 2 electrons to the right. Because I need to get this all to add up to negative 1. Now, negative 1 plus 2 minus 2 equals negative 1. So now I have a negative 1 and a negative 1 on both sides of my equation. And that balances my charge for this half reaction. Now I'm going to move on and do my reduction. So this would be step 3. So now I'm going to look at my reduction half of my reaction, and that would be Cr2O7 minus 2. Don't forget your charge. Wow, you got to be really careful about that because it's an ion. You have to show the charge, forming chromium ion. All right, I'm going to go back to first. If you look here, following your steps, I am right here. So I wrote out the half reaction for reduction. I'm going to balance the mass. I have 2 chromium here, 1 here, so I'm going to place a 2 in front. Notice what I've just done to my charge now. I don't have just 1 plus 3, I now have 2 with a plus 3 charge. So it's a plus 6 charge for this ion because I have 2 of them. Always be careful of your coefficient. Now I'm going to go ahead and balance and make my oxygens balance. I have 7 here, so I need to add how many waters? Take a guess. 7 waters on the right. So now I have 7 oxygen here, 7 oxygen here. Next thing, because I added the water, I now have to make sure I add hydrogen ion to balance out my hydrogen. So I have 7 times 2, so that's 14 hydrogen on the right. So I'm going to add 14 hydrogen ion to the left. Now I'm going to check my charge. That would be the next step down here, is balance my charge. Right now I have 14 and then minus 2, so it would be a plus 12. And then here I have plus 6. Way off, right? Way off. So what I need to do is get my charges to equal out. So over here I have plus 12, and over here I have plus 6 currently. Alright, so it's kind of like how I'm figuring out my charges. Now, you cannot become more positive, but you can become a little bit more negative by adding electrons. So I'm going to try to balance my left side so that it also equals plus 6. What could I do then? I can now add, over on my left, a certain number of electrons, 6 electrons, because 6 plus 14, so minus 6 plus 14, minus 2 will give me plus 6. So now I have a plus 6 charge on both sides of that half reaction. Now that I have both half reactions balanced by the non-hydrogen, non-oxygen, my oxygen is balanced, my hydrogen is balanced, and so is my charge. Now I'm going to do the next step in my rules, and I'm going to conserve the charge by adjusting the coefficients so that when adding them up, the electrons will cancel. You should never ever show the electrons in a balanced equation. We know that they're flowing. Now we know where they're coming from. That's really a benefit of balancing our reaction here, is to know where these electrons are flowing. But we don't see that in the end balanced equation. And so I have 6 electrons in this half reaction, and I have 2 electrons here. Just like what we did in Hess's law, or with mechanisms, how you're able to cancel things out when they appear on both sides of the equation, I want to make sure that I can cancel out my electrons. So I can multiply this whole thing. So this might be my step 4. I'm going to get rid of electrons. And so I'm going to multiply this top half reaction by 3. By doing that, it totally removes the electrons because now they cancel out. So I can cancel them out because they appear on the opposite sides. And now I'm going to be able to combine this together, showing how the 3, though, is going to have to be distributed to everything else in that top half reaction before I can actually put them all together. So I have conserved my charge by adjusting the coefficients, so my electrons have canceled. I don't have to worry about them. I'm going to combine my half reactions now. So this would be the next step. What color should I use? Again, let's go back to the green. So I'm going to go ahead in my step 5 and combine these together. So starting with the top, with those reactants, I now have 3 water and 3 nitrite. Going to the bottom reactants, that canceled, so I have 14 hydrogen ion and dichromate ion. Over for my products, going back, I have 3 nitrate, and I have 6 hydrogen ion. And then going to my bottom half reaction, I have 2 chromium ion. And let's try to scoot over. Give me more room. I'm writing too much. And 7 water. Okay, so now I have my combined reaction showing both my oxidized and my reduced parts. So I've combined it together. That's my step 5. And I want to cancel out anything in common on both sides. So let's do that. So what do I have common on both sides? Well, water. I have 3 water here and I have 7 here. Remember, whenever you balance something, you need to reduce and make sure it's the simplest. So I'm going to remove this, subtract it from here, and make that 4. And then my hydrogen ion I can also reduce, subtract 6 from here and from here to make that 8. So you see what I'm doing is I'm subtracting the hydrogen ion here, so I end up with 0. And I had subtracted the water here to make that 0. So now I'm just reducing my coefficients. Can I reduce anything else? No, because they're all different. I'm now going to rewrite this as NO2 minus. So everything that I have left, just be careful you don't miss anything. So don't be sloppy. Make sure you take your time. Always check and check and check. So you don't want to leave off of water. That could change everything. Now I'm left with this. The last thing to do, so let's go back to our steps, is to check to see that everything balances. Alright, beautiful thing about this is we could always know that we're right. So you could get the answer right 100% of the time. So I have, now look at here. I forgot to take this 3 and show that here. So that would make everything wrong. I wouldn't know that until I checked my work though. So this should be, and hopefully you caught it, there should be 3 nitrite. Right? Okay. Because that would be a way for me to catch my work, to know that I had skipped that part. So I have 3 nitrogen here, 3 here. Good on the nitrogen. Oxygen, 2, 9, 3, we're good there. Hydrogen, 8 and 8, we're good. So those are all taken care of. Let's look at our charges. I have 3 with the -1, so it's -3, plus 8, because of my positive there, -2. And over here I have -3, plus 6. Okay, so this totals +3. This side totals +3. My charge is balanced. Awesome. This is the correct answer. And I know I'm right. So that is one example of balancing a redox reaction in an acidic environment. Why? Because we have the hydrogen ion present on one side of the equation. I now am able to know the movement of my electrons, so where my electrons are moving. And what I would like for you to do then for tomorrow is to do another one on your own. So let's try out iodine ion, hypochlorite ion, to form I3, ion plus chlorine ion. So you're going to want to take it through all those steps until you get to your balanced equation. One thing, the one hint I'm going to give you is the oxidation number for I3, because it's not like this, because you have one of them, and so we know that this would be -1. But I have 3 iodine here, and it has to total a -1 charge. The only way I can do that is if my oxidation number was -1/3. You could have a fraction for an oxidation number. So that would be my oxidation number for that. And so then you could see how this is what is going to then be oxidized. Okie dokie. All right, go ahead and try it out. And this is Mrs. Ewald signing out, saying happy redox balancing. Bye-bye.